In this lesson, we'll be discussing scatter plots and correlation coefficient. At the end of the lesson, you'll be able to graph a scatter plot with and without technology, identify the correlation of the data, whether it's positive, negative, or no correlation, and compare and contrast if there's an association or causation. So correlations are slightly different from direct variation because they're not necessarily proportional. For example, the more I study, the higher the grade. But it doesn't mean if I study for 4 hours, I'm going to get an A, 3 hours, I'm going to get a B. Same like practicing baseball. The more you practice, the better you get. But if you practice for 4 hours, it does not mean you're going to get a home run, 3 hours, a triple, 2 hours, a double. Okay, it's not exactly proportional, but there is definitely a relationship. So scatter plots, when we put these two sets of data and we plot them as ordered pairs, and that way we can see if there's a strong or weak relationship, or one at all. So if there's a positive correlation, that means as x increases, y increases. Okay, so the price of a calculator and the number of its functions. So the more functions there are, the higher the price. A negative correlation is when x increases, y decreases. So for example, how long the candle is burned and how tall it is. So the longer it burns, the shorter the candle actually gets. And we can have no correlation. They're not related at all. For example, a baby's gender and the year of birth. It's not like if you were born in 1995, we had a whole bunch of boys, and then in 1996, we had all girls. Doesn't work like that. All right, so the correlation coefficient, that's just giving a number to how weak or strong. So the strength of the correlation is the R. And it tells us how close the lines are to that best fit line. And our correlation coefficient is between -1 and 1. So the negative is if our slope or our correlation is negative, and then positive is the positive. So it's how close it is to 0. So the larger the number, 0.8 or -0.8, that means there's a strong correlation. The closer to 0, the less strength of the correlation. We also got to talk about association and causation. So association, there's a relationship that they're associated, one is impacting the other, and so we can see kind of that trend. A causation is one variable is actually causing the other to happen. And then we have something called lurking variables. That means that it could have an effect on whether this relationship looks strong or weak. So association, so we're graphing the number of people at a watermelon festival and the temperature. So is there a relationship? Do more people go if the temperature is good? Yes, there's definitely a relationship, but it's not really causing one or the other. And when we talk about causation, here's one that is causing. If we're investigating the number of firefighters per month that arrive to assist an emergency fire and the seriousness of the fire. So how serious the fire is actually causing more firefighters to have to come. And then a lurking variable is they're studying the population of bees, and then suddenly there's a serious flood. So you can't really say that that's a really good relationship because that flood, which doesn't happen all the time, affected the data. So some examples. Determine if the graph shows a positive, negative, or no correlation. So if we look at this first one, we can see if we kind of draw a best fit line, that is a negative correlation. If I'm estimating the correlation coefficient, okay, it's going down, so that automatically means it's negative. And my choice is between -1 and 0. And I see most of those dots are pretty close to my line, so I would say -0.8. In this one, it is positive, but see how the points are a little more scattered? I would probably call this like maybe 0.6, 0.5, okay? It's a little subjective. And this one, there's no correlation because I could draw kind of a best fit line either way. So my correlation coefficient is going to be 0. All right, in this one, determine if it's strong, weak, positive, negative, and give us a correlation coefficient. So again, we've got this one, which is positive. When it says describe the meaning, it means like the more fat grams, the more calories. So they're both going up. As one increases, the other increases. If I'm estimating a correlation coefficient, I've got a lot of them pretty far out. So it's positive. I might say 0.7. In this one, we definitely have a negative correlation. The description is as the weight goes up, the gas mileage goes down. So the heavier vehicles do not have as good gas mileage. The points are fairly close. I would say they're closer than the example above, so I might go with 0.8. Oops, negative 0.8. Determine whether each statement is a causation or association. So this first one. The number of cold snow days and the amount of hot chocolates sold at a ski resort. Is one causing the other, or is there just an association? I would say there's just an association. Yep, the colder days probably have more hot chocolate, but it's not that close of a relationship. The number of miles driven and the amount of gas used. Oh, that's definitely causing it. The more miles you drive, you have to use more gas. The number of additional calories consumed and the amount of weight gained. Are the calories causing the weight? Yes. Okay, the more you eat, you're causing the weight gain in most people. The age of a child and his or her shoe size. Is the age impacting? Is the age causing the shoe size? I would say no, because it's not a constant. The shoe sizes go up, but it could be like a jump. Sometimes kids jump up in their size. So there's an association, but I don't think it's a causation. The amount of cars a salesperson sells and the commission he makes, that's definitely a causation. Okay, the cars impacts the commission very closely. All right, is the correlation weak, strong, positive, negative, or none? So this first one, weak, negative. The points are far away. This one, none. Here we definitely have positive, and it's pretty strong. Here again we have a positive, but it's not very strong. It's scattered, we can see it, but it's not strong. This one's definitely strong. It's almost perfect 1. This one, we've got a few outliers, but it's still pretty strong positive. Oh, this one, we've got some clusters going on, but we have no correlation. And this one, it's got a negative correlation, but it's not real tight. So when the x values and the y values increase, they both increase, it's a positive correlation. When they're not related, you can't see anything, it would be none.